So I'm going to talk about cybersecurity and intrusion detection, mostly cyber attacks through AI and how we can handle that. And I'm going to briefly introduce my research area, intrusion detection using machine learning and deep learning, and how we can make a robust intrusion detection system against adversarial examples. So I'm an honorary member of Elsevier Computers and Security. I served as a general co-chair and chair for the international conferences, and also program chair for the international conference in IoT and security. And I've been serving on technical program committee members of very renowned international conferences. I published more than 130 papers in a top venue, and my Google citations are more than 3,400. And I've been working on AI since 2001. My master thesis is about how to use machine learning techniques for detecting intrusions. Intrusion means that all the activities which violated the CIA, it's a confidentiality, integrity, and availability, which is a security goal of systems and networks. And my part of my PhD thesis is about how to preserve privacy using data mining techniques for wireless sensor network. And since then, I've been working on AI for security, how to use AI techniques to protect systems and networks. Especially I worked on how to use machine learning and recently deep learning techniques to detect network intrusions and host intrusion and so on. So I worked on the network intrusion detection system and DDoS detection and spam detection and Android malware detection. And recently, I started using the AI planning to cybersecurity automation. And that's all about machine learning applications in specific to cybersecurity domains. And this shows my research on AI security over the years. And from 2001, I worked on how to detect intrusion in host system using system calls. And then I use the network data, then use the machine learning technique to detect intrusion as well. And then I use different machine learning algorithms over the years. And then use different techniques like soft computing and the genetic algorithms and so on and so forth. Also, I try to visualize ongoing intrusion using machine learning techniques. And this shows that my journey, how to use AI techniques for detecting intrusions. And I started working on adversarial machine learning and adversarial deep learning. And recently, we have published some papers in this area as well. And if I define AI, so AI is a big set. Then under AI, machine learning is a subset of AI. And deep learning is a subset of machine learning. And we can classify the AI techniques into mainly two categories: non-security application and security application. Because I've been working on security, I define that way. Of course, this can be different based on the view of the users, but I divide them into the two categories now. And non-security applications, there are a lot of image analysis using different data sets and using different neural networks, deep learning, deep neural network and convolutional neural network and autoencoders and so on. And that can be used for the computer vision because computer vision is more about set of images rather than one snapshot of images. And that can be used for the sign recognition, and they can be used for driverless car, autonomous vehicles, and so on. And that can be also used for facial recognition systems and voice recognition system. If we use a recurrent neural network, it's very effective and efficient to recognize voices as well. And that can be can be used also natural language processing, and maybe even it can be used in advanced applications. Then how about the security applications? Intrusion detection and DDoS attack detection and spam detection. Also, there are a lot of attacks embedded in the PDF, and the malicious software can be embedded in the PDF, and they can be executed, and they can acquire privilege of target systems and network. And this can be used as binary executable analysis. The malware use a very diverse form of structures. Then machine learning can help to understand and detect ongoing malware in the binary form and so on. Why then AI is used in cybersecurity? As you are aware of, the connectivity increases. We have a 5G network, and also data volumes and velocity and variety increase as well. So over the years, so it's really hard to handle all the increasing traffic with human knowledge. And machine learning and deep learnings are really good to detect very rare events, even in spite of their high volume and very fast traffic and other type of data volume. And as you can see that there was a successful application of machine learning and deep learning in malware classification and intrusion detection. Of course, there are a lot of also research opportunity about this too. Then we need to think about AI has been used for cybersecurity. What about the cybersecurity issues for AI? So I'm interested in this area, and I'm going to talk about that a little bit today. Cybersecurity for AI. And if I use an intrusion detection as an example, let's see that we have a data set. There's two types of data set. And we may need to extract the features from here. Of course, the deep learning, we don't have to do that. But let's use a conventional machine learning technique. Then we need to extract some feature of that. How? Maybe, and this can be regarded as a classification problem, or maybe there can be anomaly detection problem, or this can be regarded as a clustering problem. Anyway, we have this data set, and we can extract some features, right? The classes and head. Also, you can measure something like that. The width of the shoulder and height of data, and so on. This is all about the feature selection and feature modification processing, data processing. And of course, if we are using deep learning, convolution layer, or other type of learning, you don't have to do this, all the feature selection and extraction. It was easier to use. Anyway, we have this type of data set. Then we may use one of the machine learning algorithm, and then we can plot them, and we can train that machine learning algorithm or deep learning algorithm, and we can get a optimal or maybe near optimal linear or nonlinear decision boundary, which can classify the data set into the two different data sets. So one is attack, or the other is benign, or one can be attack, and the other is a specific type of attacks. And now let's use this two feature variable. Of course, if you have a very large data set with a lot of features, maybe the MNIST data set, they have a huge number of feature variable. That case, this can be the hyperplane rather than nonlinear line, right? Then we have this data set, we can hex or benign. But sometimes machine learning and deep learning techniques are making mistake. It's called a false alarm in intrusion detection context. And our goal is to train the machine learning and deep learning algorithm using the data set and minimize the misclassification and increase the accuracy of that. And then it just shows one of the example I did that if we classify the DOS attack and normal patterns, then you can clearly show that they can be distinctive, and we can see that normal attacks and DDoS attack. Like this one, using multi-dimensional scaling with a 2000 training set, and I used the random forest algorithm to do that. Of course, this can be done using autoencoder and other deep learning techniques as well. And as you may be aware of, machine learning, deep learning predictions are mostly accurate. So you can see that a lot of improvement in the accuracy if we use a deep learning technique, but they are brittle against cybersecurity attacks. And the potential for sabotaging AI is very real. You can see a lot of real life example. So some example I have listed here are one research did that they pulled an AI system into misreading a stop sign by carefully positioning stickers on it. Yeah. And the second one is that one is to deceive a facial recognition system by sticking a printed pattern on glasses or hats. That's also one well-known attack. And they trick the speech recognition system into hearing phantom praise by inserting patterns of white noise in the audio. This is called the dolphin attack. So a human being cannot hear that sound at all, but hiddenly that speech recognition system can be deceived by this type of attack. And you can see all the related literature down there. And this is one example showing that graphics that the stop sign can be recognized by computer vision system as a speed limit 45, and also king penguin can be recognized as a starfish using this one. So it's really easy to fool, and then this is a brittle, machine learning and based based brittle. So how we are able to then defend against such attack, right? That's one question. And what are the then attacks? So let's look at that in more detail. And according to the adversarial example sample settings, so we can classify them into the three cases: black box, white box, and gray box. Black box means we don't know any parameters of machine learning and deep learning deployed in a certain system. And that means only we know that input and outputs, and maybe even that the limited number of access to that black box, if there is any system, protection system is deployed. White box means then we can get the parameter values of machine learning, deep learning algorithm and techniques. For example, gradient can be collected. Also, input and output can be collected as well. That's white box. And gray box means that we can have partial information on the deployed machine learning, deep learning techniques. So depending on these settings, the attack method and the difficulty of attacks will be different. And now let's look at the different types of attacks. I'm going to introduce only first two in detail, and if I have time, then I'm going to briefly mention the third and the fourth one. First, poison attack. Poison attack is, and then second is evasion attack, and third, backdoor and Trojan attack, and last one is a model stealing and extraction attacks. And poison attack is related to the backdoor attack as well. So how we can do it, I will show it how we can execute the poison attack in the next slides. First, let's look at the poison attack. And I brought up the same figure I used before. So this shows that the original boundary of two different data, one data set with the two different label information. Then if we are able to put some poisonous sample, which is also a adversarial example, when this model is trained like this way, we can put two samples or more, and then the original decision boundary will be shifted from that to this one, new decision boundary, so that all the data set which are located around here with the orange dots, that will be classified as a attack or normal. This is the attack type of the poison attack. So the purpose of poison attack is to change the decision boundary of machine learning / deep learning technique, so that this can influence decision, right? And this can be a targeted attack or untargeted attack. The targeted attack means specific class or specific labeled data can be classified wrongly, or untargeted means that some specific type attack can be classified any other types rather than its own label. That's the untargeted attack. This can be used to do that. So how this can be done with this figure? So in machine learning and deep learning, we have two phases. Normally, a training phase and testing phase. And so this poison sample can be inserted into the training data. Then it can construct a bad trained model, as I showed before. And then why then we allow this type of attack, right? Of course, that if you have enough data set, it's not a problem, right? But if you think about that, DL is data hungry. So that means we cannot afford to choose some data. Of course, if you are very confident and you have a huge volume of data already, you don't have to use untrustworthy data set at all. But sometimes it's easy to use some data which cannot verify well enough. So that's why poison attack is possible, especially when multiple parties are involved in the training. For example, it's called federated learning. Then maybe federated learning that the model parameter can be shared, or maybe some data can be shared as well, so that in this setting, in this supply chain, this poison attack is feasible, so that this poison attack can badly affect the training accuracy of model, and they can result in untargeted and targeted attacks for the machine learning and deep learning models. And next attack I'm going to go over is the evasion attack. So this can be done once all the training is done. And let's say a model is trained, then our goal is to deceive this model by generating some sample that is very similar to the malicious one, but it's not detected as a malicious one, rather detected as a benign sample. That's called evasion attacks. You want to evade or bypass the already trained model by generating example using the benign samples and or malicious samples. And if I show that with this diagram, so we want to generate this sample, which is very close to the attack samples, and the impact of these samples are similar to the attack, but they are classified as a benign sample. For example, one of the well-known attack is a denial of service attack. That means it can shut down a specific server or maybe bandwidth of the specific network systems. Then when adversarial example, especially evading adversarial example is generated, it should not be detected by the deployed machine learning and deep learning based intrusion detection system, but it can have impact. That means it can shut down the target system and or it can occupy all the bandwidth of the target networks, so that legitimate servers and legitimate users cannot use that service at all. So this is possible. So we are working on that types of attack to the real example in IoT and enterprise network. And we are working on this IDS AI. So we call it IDS. The reason is that we want to develop interpretable, dependable, secure intrusion detection system. That's why it says IDS. This is IDS square. So our goal, so as the previous speaker mentioned, that one of our goal is to make that interpretable and explainable, and using the natural language and by showing the clear boundary conditions. And this can be very useful to justify and control and improve and discover new attack patterns. The second goal of our research is that how to make that is dependable. And that means that sometimes machine learning and deep learnings are not safe enough and reliable enough, so they can fail due to accidental events and also malicious intentional events. So our focus is more about here the cyber attacks, but we need to also take into account the failure mode of machine learning and deep learning, so that we can make a bet very reliable, even though one machine learning algorithm is not well working, but the other should be ready as a backup or maybe secondary option. So one of the well-known approaches this was a primary backup system. Also in the machine learning and software computing, we use an ensemble method that can be used as to achieve this goal. The last one is a secure against a poison and evasion attack. I limited myself to the poison and evasion attack, but they can be extended to the other types of attack, such as a Trojan and the model extraction attacks as well. And if we are able to make an interpretable, dependable, secure intrusion detection system, then we may be able to trust that and you can use it. And what are I introduced different defense strategies, different attack strategies. Then what are the defense strategy? So that can be divided into the two cases. How to make the attack more robust against the security attacks, and how we can detect such examples, right? And this is a list of the strategy. Of course, it's very very high level overview. So we can use some data augmentation. It's very simple. That means when we can generate a diversity example, then that can be trained with the existing samples. That's just the data augmentation. This is very well known, but sometimes it works very well, but sometimes must not. The second one is that how we can transform the input data. So there are multiple ways. They use some filters and you can transform the input data into different space. So dimension is changed, transformed. Such thing can be used to make a machine learning and deep learning classifier or a cluster robust against this type of attack. The third one is gradient regularization. So how to find the strong parameters that even though there are a diversity example, poison attack and evasion attack, they can withstand against such examples. That's a gradient regularization. And last thing is a randomization. Of course, this is not good that good, but that's one of the robust technique to do that. And there are many other things, but this is summarize existing technology. And also we can try to detect a adversarial set if you can find a very clear boundary condition. And also we can try to map the distribution of data set if the adversarial example has a very different distribution from the benign and originally malicious traffic, then they can be identified as well. And sometimes you can use some uncertainty thresholding value to detect adversarial examples. Those are some existing ones. Of course, I don't have enough time to cover all the details, but that's the general strategy in terms of defense against adversarial examples and adversarial attacks. And what I've been working on is that I got funding from the U.S. Army Research Lab, and how we can detect intrusion in the vehicle networks and also enterprise networks. And also we are combine them with other type of proactive defense techniques. And we also try to generate attack method, attack samples using our own method. So one of the ideas is this, based on the black box setting, we only have input and output, and also sometimes gray box setting. Then we can make a surrogate model / substitute model. Then substitute model can be trained with the input and the label of the data. Then the surrogate model can be used to generate a adversarial example. Then that surrogate model can generate adversarial example. That adversarial example can be tested against the deployed machine learning model. So especially we targeted a very well-known intrusion detection for IoT networks, Kitsune, and then we tested that we can evade the state-of-art, the intrusion detection system for Internet of Things networks. And that's the second bullet point. And also we want to realize the attack and validation for software-defined networking. And also we want to combine that with the deployed NIDS. Two of my students implemented the interpretable intrusion detection system using decision tree. Of course, decision tree accuracy is low, and but we can interpret the attack, and also we can interpret the adversarial example we can generate, and we can deploy the decision tree algorithm using a well-known network-based intrusions called SNORT. And there are some other ongoing work with the students. Okay, and that's at the end of my talk about cybersecurity and adversarial examples and intrusion detection.
Okay, thank you very much. So a round of applause. I can't see if people are clapping there, but I'll clap at least.
Thank you.
Thank you very much, Dan. We do have some questions. So one question that sort of came in was, how can you make neural networks with hidden layers not be a black box and therefore make it explainable?
Yeah, so the question is about how we can make a neural network which is black box, but we can make it interpretable, right?
Mm-hmm.
Yes. If we do not know, then only way is that we can use a surrogate model. So if we do not have any idea about the architecture and the internal parameter values of the neural network, it's not possible to do that. But we can make that a little bit possible. So I can use some of this slide. Let me show the slide. Let me check. So that's related to let me share this one with you. Yeah. So can you see the screen?
Yep, AI model really.
Yes, right. This is what called a model inversion attack from extraction model. So if any deployed machine learning and deep learning technique, of course we haven't defined, but here you can see that the neural network is one of the target one. We cannot get exact architecture or parameter values from that, but using the API query, we can make a similar model which can show similar distance boundary rather than get exactly same models. Yeah. Did I answer your question? I don't know yet.
Mm-hmm. I think so, yeah.
Yeah, that's possible, yeah.
Okay. And if people in the audience have questions, please do post them on Slido. I've got a few questions of my own as well. So you mentioned the idea of a poison attack, that if the attack insert extra data samples, they can shift the boundary. Or
that's right.
In practice, how much additional data is required for an effective attack? Is it likely to be a small number, or is an attacker likely to need to be able to provide a lot of carefully engineered data to carry out a poison?
Yeah, so your question is about how much data input as a poison sample do we need to change the sim boundary? Of course, it depends on the data set type. According to some research, so this research is, let me show that poison attack. I have used that as a backup slide, so I haven't shown that. So here. So it's this paper. It can manipulate many prediction with a single poison input. So it depends. So if you have image data, so neural network is trained a long time, then it's harder to deceive that. You with a few number of few samples. But if it's an MNIST data set, you can one sample, or maybe it works sometimes. It's not always works, but that's possible to do that.
Okay. And my next question was going to be that, does this assume that the attacker has access to the model, but then you sort of explained that it is possible to engineer a surrogate model to use instead?
That's right.
Is that sort of surrogate model, how much does it make it harder to attack if you're working with a surrogate rather than the original model?
Yeah, it's pretty hard. But so if we have a lot of data set, then we can show that with the gray box model, input and output, and a little bit of parameter value, we were able to generate the risk example, which can bypass the IDS area. But it's not easy work. So it's very challenging. Yeah, very challenging. Yeah. Especially, we haven't limited our number of queries, right? So how much access we have data set. But we assume that we have access to the full data set. But if we have only a few number of samples we can get, then it's much harder. So depending on the condition of the information we can access.
Okay. So limiting the usage of the deployed system or trying to detect unusual usage patterns could also be a defense strategy.
So we have to assume that so if we query a lot to the deployed model, then there will be some system that can detect anomalies, and then it can generate alert message, then our IP address or other connection will be blocked by that security solutions.
Yeah. Okay. And you mentioned the number of defense strategies.
Yes.
Do they have negative consequences or costs? So, for example, if you're transforming the input to try and avoid the sort of block somebody from planting poison attacks, is there a potential that you lose some information when you're transforming the input and get a worse performing model as a result?
Yes, that's possible. Your question is about that. If we put a, so for example, if you put a, we retrain with a poisonous sample, then it can change boundary. And then if we have a next other poison attack or maybe similar, then it may decrease the overall accuracy of machine learning model. And as you can see that, especially in machine learning traditional and also deep learning model, if you define the region of normal sample very small, we can make it at the system very robust, but you can see a lot of false alarms in terms of false positives, right? Then if you make that larger, then we can allow a lot of false negatives. So that region is larger, then we allow that more sample can get in, so that the accuracy will be higher, but we don't know. Actually, there are a lot of false positives, right? So this is retraining or other things that can negatively affect the accuracy and other types of metrics of machine learning and deep learning algorithms. Yeah.
Okay. Again, if people have questions, please do post them to Slido. I'll ask a last question and then we'll sort of start handing over if there's no more audience questions.
Yep.
So I mean, you've talked about a range of different attacks and pointed to various papers where people have sort of engineered them and showed this can work in principle. To what extent are there known attacks that have taken place on real system by real adversaries?
So mostly the experimental level. So in the experiments and using the all known data, because and also there are a lot of tools available, like a deep pool and other tools are available. So it's easy. So I think that can be easily reality. So, but you know that one of the challenge of machine learning, deep learning is how to get the real life example and their data set. So if we are able to access to those data set, then I think it's possible to show that this is a working version. And the example I showed is somewhat real, somewhat not real. So for example, recently that the ISP, the Samsung voice command system, they collected a huge amount of data and to deceive the voice recognition system, but we cannot have access to the data set, right? They show the result. So I think it's reproducible in the real life and application, but as a researcher, we don't have access to the real data set and the real system. So one of my goals is that, let's say a company has developed intrusion system, and they said, we are very strong in detecting all different types of attack, including the adverse example. I want to test against them, but who can give that, right? What industry partners can give that data set to us? Then say that, oh yeah, so they can admit that they are weak, or that this is a really problem there.
Okay, well, if there's no further questions from the audience, then this would be a good time to thank Dan again. So thank you very much.